Physical Science 20 Introduction and Review. This goes along with the IR number 1 and 2 assignment. Significant figures are important because they tell us how much confidence we have in our answer. The confidence in the number we produce will be based on how detailed our given information was or the degree of accuracy associated with the technology we used. What figures are significant? All measured numbers are significant. And there are about 7 rules to determine what would be significant, and only 2 rules when it comes to what is not significant. So in order to make life easier, we're going to discuss what digits are not significant, and through the process of elimination, the remaining digits will be our significant figures. Rule number 1, leading zeros are never significant. First off, what is a leading zero? They are the zeros at the start of a number. So if we look at this number, it has 3 leading zeros. And this number has 2 leading zeros. This number only has 1 leading zero. And this number, it has a lot of leading zeros. There are 6 there. None of these zeros are significant. They are only here to give reference to where the decimal is located. Think about Mr. Sklar's former toad Bufo. He weighed 42 grams. Both those numbers were measured, so there are only 2 significant figures. If we were to convert his mass into kilograms, his weight would be 0.042 kilograms. Only the 4 and the 2 are significant. The zeros are not. They are only present to let us know how far behind the decimal our 2 significant figures are located. Rule number 2, trailing zeros are not significant unless there is a decimal. But first, what is a trailing zero? They are all zeros at the end of the number. So in this number, I have 3 trailing zeros. In this number, I have 2. This number only has 1 trailing zero, as does this number, with just 1 trailing zero. Some of these zeros are significant, but which are and which are not? So trailing zeros are significant unless there is a decimal. So let's say if I weighed myself on the weigh scale on the way to Regina, it would say I weigh 90 kilograms. Know that the weigh scale rounds to the nearest 10. So if I weighed 87 kilograms or 92 kilograms, as little as 85 kilograms or as much as 94 kilograms, the scale would still just say 90 kilograms. Therefore, be it concluded that 90 kilograms on the weigh scale has 1 significant figure, only that 9. But if I weighed myself on the metric scale I have at home, it would say I weigh 90 kilograms today, but maybe 89 kilograms tomorrow, or 92 kilograms after that big Christmas dinner. Therefore, be it concluded that 90 kilograms on my scale at home has 2 significant figures. The 0 is a measured number, and if my mass goes up or down, the number in the ones place will change. So on the weigh scale outside of Regina, I weigh 90 kilograms. That has 1 significant figure. So I would write it as 90 kilograms. If a decimal is not present, that 0 at the back is not significant. But if I weigh myself on the scale at home and it says 90 kilograms, I would put a decimal on the end because that 0 is measured. That 0 is a significant figure, and as soon as I add a decimal, zeros at the back of the number are significant. Scientific notation. What do all these numbers have in common? Well, first off, scientific notation expresses the value by putting only one non-zero number in front of the decimal. We got 6.3, we got 1.27, we got 2.0, we got 3.460. Each one of these numbers only has one number in front of the decimal. This is then followed by an expression of 10 to the something. And that number, that something, will identify how far the decimal was moved in that initial number. Small numbers will have negative exponents. Large numbers will have positive exponents. Often a scientist will put numbers into scientific notation. When a number is put into scientific notation, only the significant figures are used. So if a number only has 2 significant figures, only 2 numbers will be present when it is in scientific notation. I want you to start off by writing example, number of sig figs, scientific notation, and making two really long lines down your page. Our first example is 910. We don't have any leading zeros, but we do have a trailing zero. And since we don't have a decimal, that trailing zero is not significant. So this number has two sig figs, the 9 and the 1. So I will write 9.1. The decimal would move in 910. We don't have a decimal, but if we did have one, to get behind the 9, it would have to move 2 spots. 910 is a big number, so that will be times 10 to the positive 2. Our next example is 910 with 0.0 at the end. Again, we don't have any leading zeros, but we do have two trailing zeros. And zeros that are trailing are significant when we have a decimal. So these are all significant figures. We have 4 significant figures. 9100 are significant, so I'll write 9.100. And again, to get behind the 9, that decimal would have to move 2 spots. So times 10 to the positive 2. Positive 2 because 910 is a big number. Next example, 0.0091. We have 3 leading zeros, and leading zeros are never significant. So that leaves us with 2 significant figures, the 9 and the 1. So I write 9.1, and that will be times 10 to the, well, that decimal to get behind the 9 would have to move 3 spots. So times 10 to the negative 3, negative because 0.0091 is a small number. Next example is 0.0240. Leading zeros are never significant, so I'll take those out. That trailing zero is significant because the number does have a decimal. So I have 3 significant figures, 2, 4, and 0. So I write 2.40. And then that would be times 10 to the, well, that decimal had to move 2 spots to get behind the 2, so times 10 to the negative 2. Again, negative because 0.0240 is a small number. Next example is 320 decimal. I don't have any leading zeros, but I do have a trailing zero. And that trailing zero is significant because trailing zeros are significant when we have a decimal. So I have 3 significant figures, 3.20, those are my significant figures, and the decimal to get behind the 3 had to move 2 spots. So it's times 10 to the positive 2, again positive 2 because 320 is a big number. Next example is 2040. I don't have any leading zeros, but I do have a trailing zero. And trailing zeros are significant when we have a decimal, but we don't have a decimal, so that zero at the end of the number is not significant. So I have 3 significant figures. That's the 2, the 0, and the 4. So I write 2.04, and that's going to be times 10 to the 3, because the decimal moved 3 spots. Again, positive because 2040 is a big number. Next example is 2.040. I don't have any leading zeros, but I do have a trailing zero. And that trailing zero is significant because we have a decimal. So that means all these numbers are significant. So I'll write 4 significant figures and then 2.040. Now I don't have to write times 10 to the anything because the decimal didn't move. But if you did feel compelled to do so, you'd have to write times 10 to the 0 because the decimal moved 0 spots. Now if I were you, I would write IR1 and then start writing down the questions that are in the assignment and just continue on down the page. So the first one, IR1A says 925. We don't have any trailing zeros. We don't have any leading zeros. So everything's significant. So the answer would be 9.25 times 10 to the positive 2. B, I don't have any leading zeros, but I do have 3 trailing zeros, none of which are significant because we don't have a decimal. So I have 3 sig figs again. So I'll write 9.37, and that would be times 10 to the 1, 2, 3, 4, 5. Went over 5 spots. It's a big number, so times 10 to the positive 5. And that's it, the end of the lesson. So get cracking on that. If you work hard, you'll make a significant dent in this assignment, don't you? Figure?